Hello everybody, I'm Sajid Shafiqani, researcher at Institute for Studies in Physics and Mathematics and also teacher assistant in Neuroscience Academy for computational neuroscience course. I start my work by introducing univariate linear model. In univariate linear model, we have y is equal to theta multiply x plus epsilon. X is input and y is output. X can be considered as a contrast and y can be considered, for example, as a neural response. Epsilon is a white noise and theta is an Eichner parameter. In actual problems, we have different inputs or different features that these features contribute to create the value of output. Actually, we have x1, x2, xd as different features that these features create the value of y as output. Here we have theta 0 as the intercept term, theta 1, theta 2, theta d as the Eichner parameters. In actual problems, we usually have x values and y values as input and output, and we would like to estimate the values of theta parameters. In a matrix form, we have y is equal x plus theta plus epsilon. X is a design matrix. Design matrix is a matrix that different features are located in its columns, and theta is a Eichner parameters, a vector that include different parameters. For example, a vector that includes theta 0, theta 1, theta 2, theta d, and epsilon is white noise. If we have x as a regress source and y as an output, we can compute the values of theta by ordinary least square method. Ordinary least square method formulation is presented here. You can see if we compute the inverse of x transpose multiply x and multiply this term by x transpose multiply y, we can compute the estimated values of theta parameters. Here I programmed these sections in Google Colab. For in a starting point, I included NumPy and Matplotlib. Then I supposed theta values 0, -2, -3 as a theta 0, theta 1, theta 2, and I created 40 samples. After that, I created x0 as a ones matrix, ones vectors, and x1, x2 as a random numbers between -2 and +2 with uniform distribution, and I stacked these values of x0, x1, x2 as a regress source in a design matrix, and this section can be used to create the values of y. If we plot the relation between y in z-axis and x1 and x2 as features in this axis, we can see the distribution of these 40 samples in this plot. After that, we use least square method to estimate the values of theta parameters. In this section, I used the ordinary least square method to compute the values of theta hat, and this theta hat is presented here. You can see the values of theta 2 is -2, theta 3, theta 1 is -2, theta 2 is -3, and their actual values were -2 and -3. Actually, there is a little difference between estimated values and original values of parameters. After that, I tried to see that these estimated theta values can create how much of error in output. Actually, we computed the difference between estimated y by estimated theta parameters and original y as a data, and this difference can be considered as a mean square error, which here is this number. After that, I plotted this multivariate linear model, and you can see these 40 points that this point have dislocated in some sections with this hyperplane, and there is a difference between this point and hyperplane, that this difference create MSE as described at previous sections. After that, I presented polynomial regression. In polynomial regression, we can sum nonlinear terms. For example, x power 2, x power by 2 is a nonlinear term, and this nonlinear term can be included as a regressor in matrix, design matrix, and can be stacked in this section and for more computation. Thank you very much.